Welcome to Operation Deep Sleep. We are Team 16, consisting of Choi, Haley, and Rafael. So the problem that we're trying to address and combat is that we're all probably tired and not sleeping enough. So we wanted to build a device that would help us understand our sleep habits and our sleep quality. So here's what we came up with.
Yep, so our solution for this problem was to build a sleep monitor that tracks both heart rate and respiratory rate throughout the duration of one's sleep. And the ultimate goal is to analyze the time being spent in REM sleep. So based on research, we know that during REM sleep, the heart rate decreases to about 80% of what's normal, and you breathe more regularly, but your breathing rate tends to go up during REM sleep because that's typically when you dream. And so breathing becomes more shallow in this phase. And based on the idea that it's satisfactory sleep when you get about 3 to 5 REM cycles per night, that gets longer each cycle, we'll be essentially testing how many minutes people are in REM sleep throughout their duration to sort of define whether they are getting good quality sleep or not.
Okay, so the circuitry consists of the two parts that Choi mentioned, and the design is consistent with these two parts. So the first part is the heart rate monitor, which uses a voltage divider and a photoresistor to send an output that shows a peak when the heart pumps because the rush of blood obstructs the photoresistor. So you place your finger on top of that photoresistor and use ambient light as the source of light. So this signal is passed through a low pass filter and first op amp, and then it's amplified again in an inverting op amp with a large gain. And this signal is then fed to an Arduino analog pin.
And now for the respiratory monitor part of the circuit, we basically have 3 voltage dividers, and the output voltage is connected to the Arduino pins, and we're making sure that the output voltage increases with pressure put upon the force sensing resistor that we're using. And in this case, we're using exactly 3 force sensing resistors that are all going through the same identical voltage divider design, so that the peaks are about the same when they're measuring the force that's coming from the rib cage with each breathing motion.
So here's a schematic of the combined circuits, and here is a picture of the implemented circuits.
And the implementation will now be passed on to Rafael.
Hi, I'm Rafael, and this is a live view of our circuit. I'm going to go over our implementation very quickly. Here's a picture of me hooking myself up with the FSRs under the belt and actually attached to my body. To give you a quick demo of the heart rate monitor, you can see from the circuit, as soon as I put my finger on this, we start to get these peaks that correspond to my heart rate. Now, the peaks aren't always the cleanest, but it'll do for our peak detection purposes. Now, to delve into our Arduino code a little bit, this basically just gives us the readings, analog readings from the different pins that have output voltages for the FSRs and the heart rate monitors, and converts them from their original scale into the scale of how much voltage we are supplying, which in this case was 3.3 volts or 3300 millivolts. Now, to get into the MATLAB a little bit, first off, you have some presettings that you need to set. For example, your default breaths per minute and heart rate at rest when the patient is wide awake. And this is where we just set our port to where we want to be getting our data from, and then we scan that data. And then here we're getting 4 pieces of data, the 4 output voltages within the same data set. So we wanted to separate those and then perform our peak detection. And finally, based off scientifically what breaths per minute and what heart rate corresponds to a minute of time spent in REM sleep, then you detect that using, again, our peak detection methods. And here we only output the FSR1 data because you really only need one to determine REM sleep, but we use the 2 others and the heart rate monitor in conjunction because more validation for the same data is always important in science. science. And so here I can show you guys a quick demo of what the peak detection looks like. Here, the blue arrows are detecting the peaks within my heart rate for 1 minute of sleep that I had the entire 6 hours that I slept last night. This is about 79 BPM, which is good because my resting BPM is about 70. And then at the end, you see here, I have already printed out the REM sleep from FSR1, which says about 80 minutes of time spent in REM sleep, which isn't great. You should be getting about 90 to 100 minutes of sleep. So I need to sleep more.